Yeah, the finite element method works by breaking down a real object into a large number of thousands to 1 lakhs of elements, such as little tetrahedra or cubes. Then set mathematical equations predict the behavior of each element. So suppose this is your uh, real object. So we are actually dividing the real object into breaking down into finite number of elements, n number of elements. And you can see this part consists of finite number of elements such as little tetrahedra or cubes. Then after that, mathematical equations predict the behavior of each element. So this is element. So here you can see there are n number of elements. Set mathematical equations predict the behavior of each element. Then the computer combines the individual elemental behaviors to predict the behavior of the full part or assembly. So finally, the computer combines all the elemental behaviors and predict the behavior of the real object. So that is the simple definition of finite element analysis. So this finite element method predicts the behavior of parts or assemblies with regard to various mechanical phenomena. That is, you can find the mechanical stress, the displacement, what about the maximum displacement, minimum displacement, then mechanical vibration. You can find out the natural frequencies and mode shapes, then critical buckling, thermal heat transfer, and thermal stress. So that was the basic definition and important points of finite element analysis. Then next is the simulation workflow. Okay, so next is the simulation workflow in finite element analysis. So simulation use a mathematical representation of a physical system. So here you have a physical system. Simulation means the mathematical representation of a physical system. So here you can see 7 steps involved in the simulation workflow. Okay, so first you have to construct or import a part or assembly for analysis. So first you have to create a CAD model, or you can import from another software for analysis. That is the first step. Then the second step is you have to simplify it or otherwise modify the model specifically for simulation purposes. Sometimes you want to simplify your original CAD model. Okay, so I will explain this simplification in detail when I will deal with thermal analysis. Okay, just know this point. Simplify means you have to simplify your CAD model. Then after that, you have to define the material properties. So which type of material you are using? It's a Young's modulus, it's Poisson's ratio. So you have to define the material properties. Then after that, you have to fix the boundary conditions, apply boundary conditions, that is the loads, the supports. Then after that, you have to define contact conditions. So contact condition means, suppose your workpiece is an assembly, it consists of more than 2 objects. So you have to define the contact conditions. Then you have to mesh it. Meshing means you are actually dividing your object into finer elements. This process, along with defining materials, is the setup phase of the simulation. So till now, this phase is called the setup phase of the simulation, or this process is known as pre-processing. So this is very, very important. This process is called a pre-processing. So that is step number 1 to step number 3, that is called a pre-processing. Then the next is the fourth one, that is add point mass manual loads to simulate the weight of components not included in the model. Then number 5, automatically replace bodies in the model with equivalent point mass loads to simplify your analysis. Then after that, you can solve the mathematical representation of your design. Then finally, you have to review the results. Okay, so this the study of the solution results is referred to as results evaluation or post processing. So in a simulation workflow, this consists of 3 main stages. One is pre-processing, then processing, and finally post-processing. So please remember all these 3 points: pre-processing, processing, and post-processing. So that was the simulation workflow in Fusion 360. In Fusion 360 or any other FEM software. Yeah. So I will start with my tutorial. So here, this is a tutorial from Autodesk. So static stress analysis of a connecting rod assembly. So here this tutorial consists of two studies, that is study number 1 and study number 2. So first you have to constrain the model in the traditional manner, and there will be a small pin and a larger pin. So the small pin is fixed at its end faces and the load is applied to the end faces of the large pin. Then additional constraints are added to prevent the Y and Z motion of the connecting rod and large pin without inhibiting their deflection under load. So that was study number 1. So study number 1 is the model is actually a connecting rod assembly. So it is constrained in the traditional manner, statically stable, and there will be two pins, smaller pin and larger pin. The small pin is fixed at its end faces and the load is applied to the end faces of the large pin. And additional constraints are added to prevent Y and Z motion of the connecting rod and large pin without inhibiting their deflection under load. Then study number 2 is the model is partially unconstrained. The small pin is unconstrained, but the other two parts are constrained in the same way as are for study number 1. There is no X constraint anywhere on the assembly. Opposing forces are applied to the end faces of the large and small pins. And here in study number 2, remove rigid body modes option is activated. This mode is used to stabilize the model. Okay, so I hope I hope this study consists of two different studies, study number 1 and study number 2. Okay, so it will be clear when I will deal with the working. So that is study number 1 and study number 2. So I will start with the static stress study. So first you have to create the CAD model or import it from the any other software. So here this model is, I will open this model from the basic training folder. So I will click on the basic training. I will click on the basic training, and here you can see when I will click on the basic training, so you can see this option. So here these are actually tutorials. So this one is introduction, 2 is related to sketching, then this 3 is related to sculpting tutorial, 4 is modeling, 5 is managing data, 6 related to assemblies, 7 related to rendering. So I will click on the number 11. So here you can see, so I will click on this one, number 11. Okay, so I will click on number 11. I will double click on number 11. So when I will double click on number 11, you can see these are the models. These are the simulation models available in the Fusion 360. That is brake rotor, connecting rod assembly, CPU cooler, gripper arm, plastic table, plate rolling, radiator, etc. So I will open this one. This is the connecting rod assembly. So I will double click on this connecting rod assembly. I will double click on this connecting rod assembly. When I will double click on the connecting rod assembly, now you can see the connecting rod assembly is displayed in the screen. Yeah. Then the next step is you have to save this. I will save this as connecting rod assembly 2.0, and you have to fix your location. So I will enter this connecting rod assembly 2.0, then I will save this. So that is the first step. Open the CAD model and save the file. Then I will change the workspace. So here you can see this is the workspace. This is the workspace, different workspace. I will use this workspace. This is the finite element workspace. That is the simulation workspace. So I will click on the simulation workspace. This is used for performing the simulation. Now you can see a new study window is actually opened. So here in the new study window, you can see the different types of analysis options available in Fusion 360. You can do static stress analysis, modal frequency analysis, electronics cooling, thermal analysis, thermal stress analysis, structural buckling, nonlinear static stress, event simulation, and finally, you can optimize the shape. That is called a shape optimization. Okay. So here in the top, you can see simplify geometry for use in simulation. So I will deal this when I will explain the thermal analysis in detail, simplify. So I will select the static stress option. I will click on the static stress option. So here, when I will click on the static stress option, you can see its explanation is displayed in the right side. You can see static stress. You can analyze the deformation stress into the model from structural loads and constraints. So from the results, you can investigate the displacements, the stresses, common failure criteria, etc. So I will select the static stress or here I will in the bottom you can see there is an option that is called a help me choose a study type. Okay, you can use this option. You can click this and you can select your analysis. So I will click on the help me choose study option. So here, when I will click on that, you can see the different options. So I want to say, for example, if you want to see if your design will deform excessively or fail from the physical loads applied to it, so you can select linear analysis, static stress analysis. Or if you want to see the natural frequency and shape of my design as it vibrates, then you can conduct the modal analysis. Okay. Or if you want to see your long thin design will collapse under applied loads, then you can conduct the buckling analysis. Okay. So if you want to minimize the weight, or if you want to optimize your shape, you can use the shape optimization. Minimize the weight of my design by removing non-critical material while maintaining the stiffness required to support physical loads. So that is for shape optimization. So in this way, you can select your analysis, your specific analysis. So I will select the static stress analysis, linear static stress analysis. Then I will click OK. Static stress analysis, and I will click OK. Then I will change the units. So in the browser option, you can see, so here in the browser option, you can see the option that is called the units custom. So I will click on this. When I will click on this units custom, you can see the unit settings. You can change the unit settings. Okay, the default unit settings is actually custom, so you can change it into US, inches, or SI. So here you can see the corresponding units is displayed here. So from the browser, you can select the from the browser you can select the you can change the units. So I will click the default unit system and I will change the unit system to US, inches. Then I will click OK. Then the next thing is I will change the mesh settings. Okay, so I will click on the manage. Then I will click on here. So I will click on the manage tab. I will click on the manage tab. So here you can see the settings option. So I will click on the settings. So this option, I will click on the settings option. I will click on the settings option. I will click on the settings option. When I will click on the settings option, you can see settings window is displayed. So from the settings window, you can select your study type. So here you can see, you can select the study type. So the study type is actually the static stress. So you can select static stress. You can select static stress option and then go to the mesh. So here in the left side, you can see you have to enter the details of your mesh. So in the left side, you can see mesh. So you can click the mesh, and here you can see, you can select the absolute size of the mesh. So you have to change the absolute size of the mesh. So I will change the absolute size of the mesh into 0. So in the tutorial it is given that 0.1. I will enter the absolute size into 0.1. Then I will click OK. So that was the details of mesh. Then next is I will add the material. Connecting rod material is aluminum and the small and large pin is steel. I will click on the materials option. So I will click on the materials. So here I will click on the materials and then I will click on the study materials. I will click on the study materials. Then you can see a new window is actually displayed. So here you can see the three components, that is connecting rod, large pin and small pin. And you can see this column, study materials column. So I will change the study materials into aluminum. I will change the connecting rod material into aluminum 5052H32. And the large pin, it is steel AISI 1020. Steel AISI 1020-107HR. Then small pin also, it is steel AISI 1020-107HR. So here, when in the right side, you can see the properties option. So you can click on the properties tab. So when you will click on the properties, so you can see the material properties, its density, what about its density, its Young's modulus, its Poisson's ratio, yield strength, then ultimate tensile strength, thermal conductivity, thermal expansion coefficient, specific heat, etc. Okay. So when you add this material, what happens is you are adding the properties. So in this way, you can add the materials. Then I will click OK. Then you can fix your safety factor, yield strength, ultimate strength. So I will fix this as yield strength. Then I will click OK. Then, so that was about the next is constraints. So constraints means you are adding some, say, here I will add the small pin. I will add the small pin as fixed constraint. So I will select the constraints option. So I will select the constraints option. I will select the constraints option and then I will click on the structural constraints, or you can see the shortcut key is C. I will click the structural constraints option and then I will select the top and bottom face of the small pin. I will select the top and bottom face of the small pin. So when I will select the top and bottom face of the small pin, you can see this is the structural constraint and the type is fixed. And here you can see the targets. So the targets actually two faces. So two face means the top and bottom face of the small pin. And here the constraint is all degrees of freedom constraint, that is UX, UY and UZ, all degrees of freedom constraint. Then I will click OK. I will click OK. Then next thing is I will constrain the larger pin. So here I will add this constraint. Again, I will select the constraints option. First of all, I will switch off the visibility of the connecting rod. Then I will click on the structural constraint and I will select the four edges of this larger pin. And here the structural constraint type is fixed. And here I will constrain only the Z axis. Click OK. Then I will constrain the central edge in the UY. I will select constraints, structural constraints. Then I will select the central edges, target two edges, only UY, click OK. Then I will switch on the visibility of connecting rod and then I will switch off the visibility of the large pin. Then I will select the central edge of the connecting rod and then I will axis constraint as UY, click OK. Then I will switch on the visibility of the large pin. So that was about the constraints. Then next is I will apply the load, that is 2000 pound force on the large pin. So I will select the top face of the large pin. I will click loads. So I will click loads option. I will click on the loads option. Okay, so here you can see this is the loads option. So here you can see loads option. I will select the first option, that is the structural loads option. I will click the structural loads option, and I will select the top and bottom face of the large pin. Then you can see in the right side you can see a new window is actually opened, that is the structural loads window. So in the structural load window I will select this option, vectors option. So here you can see you can enter what about the force in x direction, y direction and z direction. So I will enter the fx value. I will enter the fx value. So I will enter the fx value as minus 2000 pound force. Minus 2000 pound force. I will go to the front view. So you can see the arrow minus 2000 pound force. I will click OK. So that's about the load. Then the next step is you have to add the contacts. So contacts actually means in FEM. So this object consists of three parts: connecting rod, large pin and small pin. So if there is an assembly, you have to define the contact. So what about the connection between the components? That is called the contacts. So you have to click the automatic contacts option. Then you will enter the contact detection tolerance as 0.004 inch. That is the default value. Then you have to click the generate button. When you will click on the generate button, what happens is the contact is actually generating contacts. So contacts is generated. Then the next step is you have to so I already explained in the simulation workflow the third step, that is you have to define the contact conditions. So then the next option is you have to click on the contacts option. So when you will click on the contact option, you have to manage your contacts. So this is the contacts option. So first you have to apply the automatic contacts, then you have to manage your contacts. So click on the manage contacts option. Click on the manage contacts option, and here you can see this is the contacts manager. So you can see the different contacts. Okay, then next I will change the contact type into, so here you can see the different types of contacts: bonded, separation, sliding, rough, offset, bonded. So I will select the separation contact to the all contacts. Then I will click OK. Then I will solve it. I will save this. Then next is you have to click the solve button to solve it. So I will click. If you want to see the mesh view, you have to switch on the visibility of the mesh view. So you can see the mesh view is generating. So here you can see this is the mesh view. So here you can see your object is divided into finer elements. So this is called a meshing. So then I will click on the solve button. Then I will click on the solve, then solve button. When I will click on the solve button, you can see a new window is actually open, solve window. So here you can see you can solve this using in cloud, or you can solve it locally. Okay, so here I am using the cloud. So here you can see the cloud credit account, okay, etc. So I will click on the solve one study. So I will click here. So I will click here, solve one study for solving this system. Yeah, now you can see your status is actually just moving. So this will take some time for solving the system. Yeah. Now this is completed. You can see, you can review the results. So here you can see the results. So here you can see the actual minimum safety factor. Okay, you can select, see the weakest areas of design. If you click the weakest areas of design, you can see, and you can see the different types of stresses. You can see the different types of stresses, that is von Mises stress, first principle stress, third principle stress, normal stresses. Okay, the normal xx, normal yy, normal zz, shear xy, z, etc. So you can see different types of stresses. Then you can see different types of results, such as the different types of results such as the displacement, reaction force, strain, contact pressure, etc. Okay, so that was all about the results of the static stress analysis. If you want to animate this, you can click the result tools and click the animate button to see the animation. Click the play button, or you can increase the speed as fastest. Okay, you can click one way option or two way option, etc. Okay, so also you can adjust the legend option. So legend means this is the, in the right side you can see this is called a legend. So you can control the legend. You can enlarge or decrease the size of the legend or the color transition, etc. So the next study is you have to create another study. So you have to right click on study number 1. You have to right click on study number 1. You have to right click on study number 1. I will show you in the browser. Okay, so in the browser you can see you have to right click on study number 1. You have to right click on study number 1, and you can see the first option, that is called a clone study. When you click on the clone study, what happens is a new duplicate study is generated. That is called a clone study. So you have to duplicate this. So here you can see study 2 static stress is activated. Then first you have to activate the remove rigid body modes option. So go to the settings tab, go to the settings option, and you have to activate the remove rigid body modes for stabilizing the model to prevent free body motion. Then I will delete the constraint on the smaller pin. So I will click on the load case constraints. I will click on the first constraint, delete the constraint on the small pin, and then I will apply a load. I will select the top and bottom face of the small pin, and then I will apply a load of 2000 pound force to the smaller pin in the x direction, in the positive x direction. Then I will solve this. So now you can see the this is running. So now you can see your second result is generated. So here in the browser you can see two studies, study number 1 and study number 2. Okay, so you can see the results of study number 2. So the strain, the stresses, etc. So then next is you have to compare these two studies. So for compare these two studies, you can see there is an option that is called compare option. So click this compare button for comparing these study number 1 and study number 2. So I will click on the compare option. I will click on the compare option. So when I will click on the compare option, so you can see your two studies displayed in the screen. Left will be the study number 1 and right will be study number 2. So here there is another option that is called a synchronize option. So this is for synchronizing your views. So I will select the synchronize result type. What happens is when I will select the first screen as a stress, automatically the second screen result changes into stress. So that is the use of the synchronize option. So I will select the synchronize result type. Then I will change a result of first as stress. So here you can see the second result changes to stress. So here I will change the displacement. So here you can see it is changes to displacement. So synchronized camera means if you select the synchronized camera option, when you have to select the top view as the first image, first screen, so you can see the second screen changes into top view. Okay, so you can adjust your different views. So you can change your layouts to horizontal views, to vertical views, etc. Once your comparison is completed, you can click the finish compare button. Okay, so that was all about the static stress analysis of a connecting rod assembly. So I will share the working video of this in the Google Classroom. So you have to practice it and you have to submit this as your first assignment. Okay, so thank you.